Dr. Kourtis is the Internal Analytics Principal Lead from the Center of Applied Data Science, or normally we call CADS. He's an expert with 20 years experience in delivering projects primarily in telecom companies around the globe. Throughout his career, he's been utilizing data analytics to gain insights to assist his customers in enhancing network performance and managing customer experience. He's also an expert in HR analytics, which will benefit in HR operations in recruiting talents and such. Reading his academic achievements, he obtained 2 masters, which is in mobile communications, which he furthered to his PhD and got an MBA. Alright, before we start, I would like to give a reminder to everyone to kindly mute yourself as to reduce noise and other interruptions. We're going to have Q&A session towards the end of our sharing. Please be ready with your questions or drop easily on the chat box. With that, shall we begin our talk today? Dr. Kourtis, you may start your sharing now.
Thank you, Lubna. Thank you very much for attending this this talk. Basically, what I would like to share with you is some rather things that perhaps is basically affecting you know, the world of data analytics and AI. Now, for example, this is some sort of information, sort of things that you see very often, you know, on a you see on a daily basis, really. And this is like the bad aspect of data analytics and AI that comes very, very often. Now, what you see here, this is a complaint by this guy who basically applied for basically for a loan, sorry, for a credit card, Apple's credit card in particular, and basically the automated system that Apple is using, although both of them have exactly the same income, you know, property and everything else, Apple gave to him 20 times more credit limit in the credit card than his wife. Okay, so basically, this is the problem that I see in terms of behind the scenes that affects, you know, data analytics and AI, in the terms that we have a lot of things which are effectively black box. Okay, and this is something that I'm going to discuss with you today, of what is the big problem with black box in AI. And also the other thing, which is the biases. Okay, especially we can see here that for no obvious reason, okay, the wife, I mean, took less credit card limit than his. Okay, and basically we need to understand how all these basically biases emerge. Okay, what happens in reality and how potentially we can eliminate them, okay, from our position as well. So at the beginning, we're going to talk about this issue of the black box AI. So what's a black box AI? For those of you that you're not familiar with machine learning and data analytics in general, the goal of machine learning is to create some sort of models that they are going to predict certain decisions. Okay, that's the whole idea. For example, if you want to create a machine learning in order to predict if someone is worth basically to you know, to pursue with a loan, for instance, you can create this type of model. All insurance companies and banks, financial institutions have been using these types of models for years. Okay, but the question here is that that we have different types of models that can be used. One is what is generally known as white box, okay, or clear box. This is basically a machine learning model which is very clear and very straightforward and I mean open for us to understand how decisions are taken. Okay, so for instance, if a financial institution wants to decide if a particular individual actually would default on a payment or not, okay, there is if a particular individual, for instance, poses a credit risk, then this type of sorry, let me put my laser pointer. This type of decision tree model may be used. Okay, now for those of you that you don't know, a decision tree, as you can see, has some very simple nodes, as you can see. These called features, all right? And you can see here the length of the current employment, size of the account, duration of credit, etc. Okay, and you see some thresholds. All this information basically are determined the moment that we basically train this particular prediction model. Okay, so the idea when you want to predict something, for instance, here, if an individual with whatever characteristics actually will be good in the payments or not, we take some data, which is like this. This is some very simple, you know, table data. Okay, we train a model. In this particular, we train this type of decision tree, and we see what are the decisions that this model is going to follow. This, you see all these thresholds basically here, whenever a new prediction basically will be required. All right. So the good thing about this type of machine learning models is that we have very, very good visibility. And if any questions basically comes back to us as organization, you know, from customers, like why I wasn't accepted, you know, this loan, we know specifically to say that, okay, this decision, I mean, you weren't given this credit because you fulfill this type of combinations, basically, as you can see from here. All right. Now, the problem with black box AI, okay, is that there are a lot of models out there. For instance, you have the deep learning. I'm sure that you know a lot of deep learning models these days, okay? And these basically, they don't give any visibility whatsoever of how a decision was taken. So for instance, if we train our model again with the same data as you have here, okay, you see the input here of the model, which is exactly the same sort of information, but what happens inside here is completely obscure to us. We cannot really see what is going on. The only thing that we see is the yes or no, but what was really the inner workings of the model that resulted in this decision, it is something that we don't know. All right, and this is basically the problem with black box AI and what happens really behind the scenes on this type of models. All right. Now, in terms of what happens with the models in general of machine learning, they are split into two different categories. One is basically the black box techniques. I'm not going into the details. This is only for people who know, and this is more for reference. Deep learning, it is something perhaps most of you know or have heard. Okay, this is a technique, for instance, that it is used a lot for image, for instance, detection. Okay, and all the others basically, as you can see. And you see here the list of techniques, machine learning techniques, which are known as interpretable. All right. This type of techniques this is the decision tree. You see the decision tree that we discussed earlier. And perhaps some of you, if you have any type of STEM background, you know about linear regressions. Okay, so linear regression is one of these techniques. In general, these techniques are interpretable because if you use it, the model that will be generated is completely open. Okay, and if there is a question of why basically, you know, a decision was taken, it is very clear and open for us to discuss about this, exactly as it was with a decision with the decision trees earlier. All right. Now, the problem with black box is that black box techniques have superior performance. That's why basically companies and organizations are using it. There is no comparison between black box and interpretable techniques. And this is the reason now why there is a big trade-off of should we go for superior performance or not? All right. Now, of course, because of the performance, you know, a lot of research has been taken in order to generate frameworks and tools that will help you to actually explain the results of a black box AI. Now, problem is that it is possible, but not always. Okay, so what you will see in general when we talk about explaining AI is that there are two approaches. Okay, one to have a global understanding of how the model basically works. Okay, or, and this is known as global explainability. And the second one is a local explainability, which is basically looking at why a particular decision was taken for a single one. All right. Now, the first one, the global explainability, there are a lot of frameworks out there that give us, for instance, a type of overall view of which of the features of the models are most important, which looks like this. Okay, this is any prediction model, okay, that generates a black box, will give you this sort of list of feature importance. Okay, by feature importance, it means whenever a decision is taken, okay, which one of the features is the most important and which one on average basically takes more priority than the others. All right, so by global explainability, if we have any black box solution, we can basically see on average how decisions are taken. But remember, the key point is the on average. Okay, when it comes like the you know, the guy that was complaining at the beginning about the Apple Card, why he was given more actually credit limit than his wife. This is a local explainability issue, why this decision was different. Unfortunately, there are no solutions now that can help you with this type of request. Okay, and this is basically the big problem with all these issues, that we cannot, if there is a request to explain specifically why why a decision was taken, it is not possible to achieve that. So overall, if you want to see what happens between black box and interpretable AI, we have here, remember the solutions that exist in terms of interpretable AI are less complex, easier to build, okay, because the models are not that complicated, and basically cheaper to build, and of course, easier to run, all right? However, the problem is that always they come with lower accuracy, all right? On the other hand, when we talk about black box AI, we talk about higher performance, higher accuracy, okay, overall higher performance. That's why basically all the companies like, you know, Google, for instance, Microsoft and things like that, in general, Apple, with the example that we discussed earlier, they use black box AI in their solutions because they have higher accuracy. Okay. But overall, in terms of the higher accuracy of these models or the lower accuracy of the simpler models, it is a matter of let's say a decision within the organization to decide what actually meets your requirements without basically paying the penalty of the lower accuracy. Okay, everything is a trade-off, effectively. For the black box AI, you should be careful if potentially you are going ahead and build this type of models and use this type of models in your organization. Okay, that if there is a need actually to create an explanation framework, this maybe is not going to work. Okay, and you may have additional costs, you know, whenever you're going to effectively deploy and use this type of models. So in general, and this is something that you should think of when you talk about basically black boxes. There are certain techniques, black box techniques, like the XGBoost, for instance, that a lot of that since it emerges, you know, some years ago and won some CADS competitions. They for data science teams, these techniques are the big hammer that they use everywhere. Okay, and you understand what we talk by big hammer. Okay, that they find everything as nails and they use it in order to solve all problems with these black box techniques. Okay, I have nothing against these black box techniques. Okay, they are fantastic. I have used them for sure, but we need to be careful when we are using them. Okay, that's why basically this is what I would like to stress basically with you. Another important issue that emerges, actually, this is from Europe, but I think it will come from across the world. I'm sure that you are familiar with GDPR. Okay, problem is that GDPR is not looking only on the data of your customers, okay, and how you are using them, but also GDPR now provides the right to the customer to ask the organization why a decision was taken. So for instance, the Apple in Europe must be able to respond to the customer, like the case that we discussed earlier, why, you know, his wife took less credit limit than he. Okay, and there must be a full explanation. Hence, for this type of applications, black box solutions cannot be used, okay, under GDPR. And because of that, you can understand that there are massive, basically, implications in finance, healthcare, and insurance, meaning that solutions that are interpretable perhaps are better, regardless of the fact that the penalty that you pay in terms of less accuracy. Now, in the next part of the in the next half of the presentation, I would like to discuss another thing that affects really the AI, okay, and the data analytics, and this is the biases that come in the algorithm of the algorithms. Now, for those of you that you don't know, when we talk about text mining, is basically the process of using any type of text data, unstructured text data. For your organizations, this can be anything like job descriptions, resumes, okay, customer reviews, you know, things like that, anything that you can use, that you can analyze them using one of the existing NLP techniques in order to extract information. This can be any type of information, depending your business case. Okay, so if it is, if you're working with from an HR point of view, using this information can be used in order to extract the skills that your employees actually know. If it is from a marketing point of view, you can use this information to extract what the people think about your products. Okay, so this is valuable information that you can extract using these basically systems. Now, these systems can be either used, there are a lot of off-the-shelf systems that you can use, free or not, okay, or you can build one or your own, all right? Now, what I would like to discuss here is the problem of using one of the existing systems that exist out there, okay? Now, there is something that many people, they don't know, and this is how this type of systems actually work, okay? And when we talk about systems, we talk about, like, maybe you have heard Google's BERT system or Microsoft GPT-3, okay? Or from Stanford University, the Globe, okay? All these systems are NLP systems that will help you basically to extract data, okay, information from any text. Now, how these systems basically are trained? What they do is that they create these constructs. We call them word embedding. Word embedding is effectively constructs created in order to make these systems actually make sense of words. So, for instance, a word like mom for the system doesn't mean anything, but we train it in order to associate mom with dad. Okay, so these two, whenever they are together, they are basically related. Okay, and effectively we train it to associate words mom with dad instead of mom with ketchup or dad with butter and things like that. Okay, in this way we sort of create this sort of word embeddings, making similar words for as we use them, and we create this information within these systems. Now, what is the problem? The problem is that these bots now, they scan the entire internet and they use the text already there, okay, in order to create this basically knowledge graphs, all right? So the problem is, of course, that all the text out there in the websites, there is a lot of biases. All the biases that we have actually are reflected into these type of documents that the bots find out, okay? So for instance, if the bot goes to this first website, what's it going to see? It's going to find the word man, as you can see here. It's not red, but anyway, you can see this, all right? And very close to this word, it finds other words like angry, like science, like doctor, or like career, all right? And by close, we literally mean distance in terms of words. Okay, so the closer these words are to the word man, this system will think that there is an association between the word man and these words. All right. Now, if this same system goes to another website, it will find the word woman, as you can see here, very close to other words that appear regularly, like nurse, like family, or like son. Okay. Again, another association will happen, as you can see, woman, nurse, okay, in terms of work and family, that perhaps women in general are more associated with families. Okay. Again, another, in terms of men, we have here, and this is basically angry, and another one with women looking about families. So word embedding bots go out there trying to find out how words relate to each other. Remember, they are not intelligent, okay, these bots. They just try to relate words to each other in order to create these word embeddings, in order to help the system extract information. Okay, effectively, these bots copy our biases, all right? So what are our biases at the end of this process? And this happens across all NLP systems out there, is that these knowledge graphs are created that represent exactly the problem. And as you can see here, the word man, okay, is associated with career, okay, man-like type professions like doctor, being a scientist, and things like that. And in general, the men are more angry, okay, in terms of their feelings. Women, on the other hand, they are more family orientated, okay. At best, they are going to do some nursing job, okay, and always they are sad, you know, and they have this type of feelings, basically. Okay, what I'm showing you here, this is something that is the basically the output of this crawling that all these basically bots are doing in order to put meaning in the words. And effectively, the bad thing is that they replicate exactly what we think, okay, about that. And that's true. I mean, I can tell you for Greece, okay, but this happens actually. This is specifically for the US, okay, that this type of knowledge graphs and associations are valid, okay. And they are because they are caught in action, okay. Perhaps you have heard in Amazon some time ago, there was this problem that Amazon HR hired only male candidates. Why was that? Because Amazon had this automated, basically screening sort of system that everyone was placing basically their CVs, okay, and effectively these CVs, they were of course analyzed by these NLP systems, the Amazon's NLP system that was created. And of course, the problem was that based on this type of bias knowledge charts that they were created, the only male candidates were passing through, because effectively, or the female, they were considered as not worth not worth pursuing because of family orientation or things like that. Okay, so this is a big problem, and that was really an issue why Amazon actually failed to hire any female, basically software developers, primarily because of this screening taking place in the CVs. Next problem, of course, is when you have AI that it is not trained sufficiently. Okay, this is the situation when you have selection bias, as we call it. Okay, it was and this was the case until very recently, that all face recognition apps they were able to distinguish only white men, okay, and nothing else. I mean, for dark-skinned women and anything other combinations, basically the systems basically didn't work, simply because the AI algorithms were not fed with sufficient data to train themselves. And also another sort of issue in terms of bias is that comes from Google and LinkedIn. I'm sure that you have used LinkedIn, okay, and you know that LinkedIn actually is using basically is promoting jobs for you. Now, the problem with the bias, okay, and the same sort of bias sort of knowledge graphs that they have created is that it is guaranteed that if you are a woman, you would see a lower paying job ads with in comparison to if you are a man. Okay, and this is basically the problem, okay, of bias and how they are propagated basically in general, because the platforms actually they were pushing, because this was happening, you can understand this because platforms they were considering men as career driven. Okay, so high paying jobs is only for career people like men. Women, they will, maybe get one job. After that, they will go to raise a family, basically. Okay, so this is again the reason behind these word embeddings, how this basically happened. All right. Now, okay. Now, some other biases that it's very important to have in mind is basically what we call as labeling bias. Now, have a look at this, okay, and think of what label actually you would put, okay. Now, if I don't tell you anything about the context, and this is something actually as a small experiment that I do regularly with all the trainings basically that I give, is that most really of my students, whenever I do this, they basically put as a label that there is a worker, which is basically the woman, that is called by her boss. Okay, but be careful. I haven't mentioned anything about, work environment, boss or not, or whatever. So you shouldn't really, and this is a very big, basically, problem that we, including myself, we propagate biases in this that affects basically the algorithms that are working for us. Okay, so effectively, we need to be careful about this, and actually, what is the problem here is that, like I said, we have the labeling bias sort of issue. Okay, a lot of machine learning algorithms, they require label data in order to train themselves. A lot of this data actually are already biased. This Flickr 30,000K data set, it is one that it was crowdsourced, that was a few years ago, and it was used extensively actually to train algorithms used by Facebook, for instance, in order to detect what basically exists in these images. Okay, and basically the people that they were labeling these images, actually they were biased, and they were putting this type of labels, as you can see here. The correct is the first one: a blonde girl and a bald boy and the bald man with his arm crossed are standing inside looking at each other, nothing else. Okay, this is really what happens in this situation. Everything else is things that we have in our mind, and basically we try to replicate, okay, which is really, really important to always think of what we see, okay. Now, the next thing about text mining is that since we discussed about all these knowledge graphs and the biases that are generated, it is very important for you to remember that in your organizations, if you use it, it is almost certain that biased information actually will be generated. Okay, We discussed about HR generating different skills for your employees if you work in HR. If you work in marketing, you will get different customer reviews, okay, information in terms of online and social media, okay. All of this type of information is basically biased, okay. Now, the systems in general that are using this, it's not something that I'm saying that they are biased. There has been extensive research over the last few years in order to identify specifically what type of biases these systems are propagating. Okay, and you can see here that that was a very interesting piece of research a few years back. Analyzed 219 basically NLP systems specifically for sentiment analysis, okay, in order to see if they are biased or not, okay. And basically it was a very clear cut that males are associated with these feelings and females with different, okay. And basically this is information that of course needs to be taken very, very carefully whenever we basically are the receivers of any type of NLP text mining sort of output, okay. And of course the same is the same sort of research has proved this type of basically biases that exist as well. Now, the problem, as you can see, if you're working in an organization and have this type of basically output is, I mean, there are major ethical implications, okay? So what basically, how you should work now with this? Should we actually take into consideration the biases and try to either fix them or avoid them? Or basically, are you try to exploit them? Okay, because especially when you talk about the negative female bias, okay, that we have here, okay, this is something that a lot of companies, especially in terms of marketing, promoting, you know, things, this is something that can be basically exploited, okay, and this is raising a lot of issues, as a matter of fact. Now, the good news, of course, is that everyone, you know, we use basically machine learning. We build models, or we have teams that they are building. It is important, you know, to be clear that we are able to, you know, to stop these biases. Okay, and the biases, as we discussed, comes either from a biased algorithm as it was designed originally, or from the data that was used actually to train that algorithm. It's very important always to be careful, okay, that whatever we put out there potentially, either directly or not, would impact individuals, okay, and we need to be very, very careful on this one. Now, the goal, of course, is that if it comes with the data that are used in order to train an algorithm, these must be diversified. They need to basically be able to represent the entire basically I mean, customers or individuals that is targeting the algorithm, the prediction model is targeting, okay, and it's very, very important not to have any biases there. So this is very important to our data science teams, for instance, that are going to build these types of algorithms, to have the capability to have diversified data, okay. And of course, in order to identify this type of sort of biases in the data, the data science teams must be able to use statistical methods in order to find them. Okay, So, and this is something else also that you should have in mind, is that all data scientists, because at the moment there is a lot of discussion about machine learning and AI, which is fine, but also for me, it is important that they know very well statistical analysis in order to identify these problems, okay? Because the whole set of knowledge is needed for a good data scientist these days. Finally, it's very important, you, as you work in groups or you're going to build your teams, they need to be diverse, because you know everyone comes with their own biases, okay? We need to have different diverse teams in order to see things before go into you know, into production, into affecting customers from different view, okay? And this is something that basically that is very, very important, that you should have also in mind as we finish this basically presentation. So the key takeaways are basically here. I think I'm going to stop the presentation now, and I'm happy to thank you very much for your attention, first of all, and I'm free. Please let me know if you have any questions. I'm happy to answer them.
Thank you so much, Dr. Kourtis, for your sharing today. We explored a lot about today's topic. Now we have arrived to the time of Q&A session. Do you have questions related from the floor? You may also speak directly with Dr. Kourtis or may drop your questions in the chat box. Do you have any questions? Maybe in related to NLP or stopping, related to data science. I think it's maybe about the timing. It's the afternoon session.
I know.
So everyone, yeah. So everyone is quite, yeah.
Yeah, no.
It's okay. Maybe
It's
I'll give
before the
some room to
weekend.
think. Yeah, it's okay.
Yeah, I know, I know.
Yeah. But actually, Dr. Curtis,
Yes, yes.
yeah, um, as you mentioned about those data science and um, about your topic, I used to learn it during my master's degree in USM. So I think all of your sharing is quite spark to me during my study years. So
Mhm.
yeah. So yeah, maybe I can use it to further my studies. Maybe in the
Yes, of course,
meantime.
of course, of course.
Okay,
Because I
hello.
think, yeah,
Yeah.
it's yeah, is someone?
Hello,
Yeah.
can I ask?
Yeah.
Yes, of course.
My name is Khairul. I'm from Petronas. So
Mhm.
we are currently in Petronas. We are also undertaking a lot of digital solutioning internally. And as you said here, you need to train algorithm with WS about data. Can you elaborate this data? Is it, for example, a pictures, or for example, we are doing artificial intelligence to tell the operator the equipment is going to fail? So what we did, we took the pressure level, temperature, and all the measurement that we had for the last how many years, and then I think the AI built themselves something, and then we can see the differences. So I think what I'm talking about here is more towards equipment, but what your example just now, the bias, I'm not sure equipment will have bias or not, because equipment, whether in US, in Europe, in Asia, equipment pump is pump, right? But now, if I'm trying to go back to what you explained about the bias in data, especially for the party who is trying to do for people, the product is for people, what data are we looking at? is it the mindset when you key in the logic? If this guy is white, this is what, you know. If this guy is black, this is what type of data are we talking about here? So what I'm asking that, then we need to know from whom we should get the data. That's the intention of my question. Thank you.
Yes, that's a very good question. Yeah, of course. Yeah, of course, it depends on the situation. Okay, and basically this is what I discussed in terms of how you're going to use this model. As you said, okay, of course, if you create a prediction model, for instance, to predict this sort of when some preventive maintenance you're going to make, for instance, in your equipment, okay, because this not necessarily interacts with individuals, okay, it can be a black box, okay, not necessarily, you don't necessarily have to use an interpretable AI solution. Although there could be the case in some organizations that because the internal stakeholders actually, they need to understand why you take my machine off for maintenance, they need really the justification. So in this case, maybe you will need to do some interpretable AI application, really. Okay, but in terms of the bias, okay, this is something again that could be the case in your equipment as well, because maybe we have the biases that affects people, which is very important, okay, and the biases that affect you know, how the equipment basically work. And this can be the case if for instance, the you know, the data scientists that created these models, maybe they didn't see holistically the whole thing in terms of creating the initial algorithms, but maybe also during the data collection and application, they fail to use some things. Okay, remember, we have biases and we need to fight always against this. This could be the case that affected basically, that could affect your equipment and the performance of this model. Okay. Did I answer your
Thank you.
question? Yep. Okay, great. Thank you. Anyone else? I think I saw some hands actually.
Anyone else?
Anyone else?
Let me see. All right. If there is no other questions, we are heading to wrap our session today.
Sure.
But before we are ending our session, can we have some short remarks, closing remarks from you, Doctor, please?
Yeah, of course. Basically, what I would like to discuss with you, it was because all of us will be either users of machine learning AI or consumers, let's say, will be affected from that. There is a lot of gray area at the moment in terms of how this affects our lives. Because this is something that I'm working and using, you know, for several years now. Okay, and I see, you know, especially with GDPR, how you know, there is this pressure for clarity basically across everything. It is especially for people, you know, in the group that are learning, you know, and they start their journey now in becoming data scientists, is actually building their expertise in these aspects as well. Okay, not looking only for what was the top basically prediction model that won the last Kaggle or sort of contest. Okay, but be more open with the problems, with either the business problems or whatever is the problem. Okay, and finding the best solution holistically, really, not really just took this, find, and that's it, finished. Okay, so that's what basically I would like to share with you as final remark about this. Okay.
All right, thank you so much, Doctor, for your sharing today.